Hello, I, Sanjana Gajjar, am going to speak on the topic of exoplanet hunting methods, which is my topic for the final assessment of NAT161 Astronomy. What are exoplanets? All planets, apart from the ones in our solar system, are referred to as exoplanets by us. The first ever exoplanet to be discovered was 51 Pegasi b, and now over 5,009 exoplanets have been discovered using various exoplanet hunting methods like the transit method, radial velocity method, gravitational microlensing, etc. to name a few. Next slide. The radial velocity method, also known as the Doppler spectroscopy, detects the presence of an exoplanet by observing the wobbling or back and forth motion of a star. This movement is caused due to tug-of-war of gravitational pulls between the star and the exoplanet, which is especially high when the star is of a lower mass. Next slide. These movements are deducted using a spectrometer to see whether the star red shifted, moved away from the observer, or blue shifted, moved towards the observer due to Doppler effect. These movements are also recorded graphically using HARPS, which stands for High Accuracy Radial Velocity Planet Searcher. Proxima Centauri b, the closest exoplanet to Earth, was also detected using the radial velocity method. Next slide. Radial velocity method is best implemented when the star and the exoplanet form an angle of inclination of 90 degrees with the line of sight of the observer. Radial velocity method was the first successful means of exoplanet detection and identification. The RV method detects planets the best around low mass stars like the M-type stars, which are also believed to have the most likelihood of having habitable planets, and hence radial velocity method is very useful to us in that way. Some drawbacks of radial velocity method include the production of false signals due to overlapping magnetic fields and stellar activity, or the inability to observe multiple stars simultaneously and detect sensitive wobbling movements. Next slide. The transit method of finding exoplanets, also known as the eclipse method, detects the dimness in the star even for a brief period of time when an exoplanet passes between the star and the observer. Next slide. The temporary dip recurs every time the exoplanet completes one orbit around the star, and this is graphically plotted as a light curve to confirm the presence of an exoplanet. This helps in measuring the orbital period of the planet, and with the help of the laws of motion and the star's estimate mass, the planet's distance from the star can be calculated. The diameter in which the dimness occurs can also be used to find the size of the exoplanet, and also its mass can be deducted from it. The transit method can produce multiple light curves simultaneously, which helps us in finding exoplanet solar systems. So maybe a solar system like ours. Next slide. The Kepler mission was initiated to find exoplanets using the transit method, and it is known for its high reliability rate and the statistical methods used to discover about 3,500 exoplanets, out of which 100 are located in the Goldilocks zone, also known as the habitable zone, wherein temperatures are neither too high nor too low, so water can exist in liquid form. Till date, 3,879 exoplanets have been discovered by the transit method and 936 by the radial velocity method. So, I personally feel that the transit method is better at successfully finding exoplanets, and it can also tell us more about the orbit size, planet size, composition of the planet, etc. The most intriguing part about this assignment for me was that there's endless chance of life out there in the universe, and these hunting methods that are implemented thousands of light years away from us are yet so successful that truly shows how wondrous science is. Thank you so much. With this, I would be ending my presentation.